Okie dokie. All right. Hi, Redway. Awesome. Okay, so let's get started. Um, so hopefully by today, so last class we just looked at getting VS Code set up and being able to run a Java program. Um, if you weren't here, then come see me afterwards or come to office hours tomorrow and we'll get going. So yesterday we looked at how to install Java, how to make a Java project. There's some things that I am I'm still learning about using VS Code for Java. In previous iterations of this class, I was using Eclipse. So that's more what I'm used to. And so since you all here in this department are using VS Code, I'm transitioning to so that you all are using the same thing, and VS Code is also like widely used everywhere. So that's why we're doing this. But for me, it's also a bit of a transition. So I may tell you things that are not optimal and then realize later, oh, wait, yeah, there's a easier way to do this. So one of the things is to create a new Java file. The easiest way is to do, let's see, do I have this? Yeah, so if you're on Windows, to do Control-Shift-P, that opens up this command palette. If you're on Mac, Command-Shift-P does the same thing. So Command-Shift-P or Control-Shift-P opens up some window over here like this, where you've got some text box and there's the little angle bracket and you type something here. So this is where you type important things to do in VS Code. And so here's where we typed like create Java project. To make a new Java file, we would say, if I just type Java file, then one of the things that shows up for me is new Java file. So if I wanted to make that, I can click it or hit enter. And then I get to this selection screen where I can create a class, I can make an interface, an enum, a record, annotation, or an abstract class. We'll talk about like interface and abstract class later. What we care about right now is class. So we hit class, and then we give the class name. When you give class names, you're going to want to have a capital letter. That's typical for Java. So I can do like some class dot Java. So technically having a lowercase letter, it doesn't give you any errors, but we want, when we're naming a class, we want capital letters. So then once I'm done, I can hit enter, and then it brings up public class, some class, and now I can type my code and do what I want here. So again, how we got there was Control-Shift-P on Windows, Command-Shift-P on Mac. That brings up this. We go to new Java file, hit class, and then give it a name, hit enter. So that's what we're going to do to make new Java files, new classes. One of the other things I saw in the active learning submissions is if you wrote X colon in the print statement, you don't need to do that. That just, for me, it shows up automatically. So like if I go to my hello, there is like an X here. I didn't type that. VS Code just added it automatically. If you know of a way to turn that off, please let me know. But you don't need to type that. It just shows up. Don't worry about it. The third announcement, make sure your notifications are right in Canvas. So if I go to Canvas, let's go to so I think it's actually in account. So on Canvas, there's like the left sidebar, click account, go to notifications. I'll put it in a new tab. And there's different course activities. The two things that I want you to have immediately that I prefer are announcements, because that's where I'm sending out maybe timely information like, hey, there's an assignment due in half an hour, don't forget. And then if you get that like at 5 p.m., doesn't do you much good. And then the other thing is submission comment. Because when you submit something, I will write a comment on your assignment. So I would like you to be able to see that. So that's how I'll communicate any information about grades. So make sure submission comments and announcements are good to go. The other thing, so lab 1 is now officially assigned. So you can start working on it. It's due Monday night. And you can get there. So if we go in Canvas, lab 1's over here on the sidebar. So you go to a GitHub link for lab instructions. And if you go here, you can read through it and it gives you all the information that you need to do the lab and get it done. You can read some documentation. So what you can do, you can work with a partner. Yeah, question.
I was like creating like some concept Java and saying like it's giving me a bunch of errors,
What sort of errors?
like a bunch of red errors.
Okay, let's talk afterwards. Do you have the hello.java that we worked on last time?
Yeah.
Okay, yeah, we're gonna work in that file today. Okay, so for lab, you can choose a partner in this class. You could also work on it by yourself. It's easier if you work with a partner. But in any case, the lab's designed to be done with in like an hour and a half. Sit down, work on the lab, done. So if you work with a partner, you can work on one piece of code, like one person has the computer and they're typing, but then just make sure to like send a copy to your partner and both of you submit it. And just in Canvas comments, just write, I worked with person X. So you can do pair programming, which is where if you're working with a partner, one of you is the driver, one of you is the navigator. So the driver, that's the person in charge of the computer and keyboard, and they're typing the things. The navigator is like, let's type this. Let's do this now. So, but it's not, neither of the people are in charge. You're both responsible for working and getting towards the solution. It's just one of the techniques that you can use to get this done. Okay, so for the lab, the instructions are here. You've got VS Code, hopefully. You've got the Java development kit. You'll clone the repository from GitHub. This tells you how to do it. I've got pictures. And then, yeah, so then you'll go through the instructions and actually do some coding and write solutions. Yeah, if we have some time at the end of today, I'll give time for you to work on it. But I'll let you, this is for you to work on now. Okay, so that's lab 1. One of the things that I have learned transitioning from being a student to being a teacher is that questions are great. Like if someone asks me a question, I'm like, yes, I've succeeded as a teacher for the day. Someone is engaging. So if you have a question or a comment, let me know. I appreciate them. Anytime. I've got office hours tomorrow, 4 to 5. If 4 to 5 doesn't work for you, I've got wiggle room. 3 to 4 is my office hours for my 102 students. But if no one's there, feel free to show up. But they get priority if they do show up. And if you need time after, I can also stay late. The other thing, in the active learning assignment, this is the last announcement for today, I promise. The active learning assignment, there's a when to meet. The department is trying to figure out, we want to have an ice cream social for like the math, CS, and I think physics majors. So this helps us to figure out who is interested. Are you interested? What time should we have it? So fill that out. And we would appreciate that. Okay. Any announcements from the class? Questions, comments, concerns? Yeah.
Turn off like the X colon thing if you go to inlay hints in the settings button.
Inline hints. VS codes.
Or like the.
Oh.
Yeah.
Setting.
Inlay.
Say that again.
Inlay.
Inlay. INLAY? Okay. All right, let's see how this works. Okay. Awesome, thank you. Any other comments? All right, let's get started. Okay. So hopefully you have your Hello World. We worked on that Tuesday. We talked about this slide. Now we get to talk about the primitive types of Java. So there's more simple types of variables in Java, and then there's more complex types of variables. So it's broken into what we call primitive and reference types. We'll talk about reference types later. For now, we're looking at primitives. So there's 8 kinds of primitive types. These are variables that we can make of these types. So there's a byte, which is an integer that's only 8 bits long. It's broken into like byte, short, int, and long. Those are the integers, so like whole numbers. And then float and double, those are like decimal points, numbers with decimal points. And then there's char and Boolean. And so the difference between like a byte and a long is basically how big the number is. Because if your integer has a bunch of digits, that's going to take more space in memory than an integer that's like only 1 digit. So that's the difference between like the number of bits in the integer. It's basically how much space we need in memory to store this number. There's some examples where later we'll work with really big numbers, and sometimes it goes overflow. So like we have a number that's too big, so we need to increase the precision for that variable. Char is a Unicode character, so that's just one character on your keyboard. And in Java, we do that with single quotes. So this is something where Python and Java differ, where in Python, we can use single quotes or double quotes, doesn't matter, as long as you match the beginning and end. In Java, single quotes does something different than double quotes. So in Java, for a string, which is like a bunch of characters, so I can say string s equals some number of characters. My string has to start with double quotes and end with double quotes. And if I want a character, so just one character, it has to be, let me put an equal sign in there. It has to be, let's also give the variable a name. It has to be single quotes. So we can't, so if I tried to change this string to single quotes, gives me an error. That's the red squiggly line. It says invalid character constant, which means I said here, I'm giving you single quotes, So it's expecting a character, and then it's like, you gave me a bunch of characters. Why did you do that? That's not what I'm looking for. So for strings, we need double quotes. For single characters, single quotes. Booleans are either true or false. Did you work with those in programming 1? Okay, seeing some nods. So we can have something like Boolean B is equal to true. In Java, true and false is spelled lowercase true, lowercase false. In Python, it was capital T true, capital F false, but here it's all lowercase. So if I move this out of the way, if I tried to say capital F false, then it's like, what's false? I don't know what that is. So making lowercase. Declaring variables in Java looks a little bit different from Python. In Python, we could say like x equals 5, and that's fine. In Java, we need to give a little more information. So you'll notice so far we have some word here, then we've got a variable name, then we've got equal sign, and then whatever the variable equals. So it's value. So these are so the thing on the very left-hand side, that's what we call the type. So the type of the variable we call S is string. The type of variable C is char, character. The type of variable B and F are both Boolean. Okay, I think we got that so far. Yeah, so we have to declare a variable before using it. So what that's doing is it's going to set aside a space in memory where we say, this is my variable. I'm going to have something where I store some data. And I have to say, here's what type of data that is. And then once that's done, then I can use it. So here, so let's say, here I'm declaring variables. And so one way of doing it is just all in one line where I have declare and initialize, where the thing on the left side is saying, this is the variable, this is what type it is, that's declaring it. On the right-hand side, when I'm setting it equal to something, that's initializing it. It's setting that initial value. We can just declare. We can just declare by saying like int x. And so what that's doing is it's saying, I'm going to have a variable called x. Its type will be int, and I'll use it later. And so for now, we've got warnings over here. That's the yellow squiggly lines. Those warnings are just basically, you have this variable and you never used it. What's with that? But it's a warning, so it'll compile just fine. In terms of variable names, you probably went over this in Python. Same rules typically apply. The variable names are case sensitive. That means something like, so let's, so I can set up multiple variables, declare them up here. And ABC, A capital B, C, and A capital B, capital C, those are all different variables. So case sensitive, absolutely. So our variables are case sensitive. letters, numbers, underscores in the variable names, all fair game. You can use those. It should start with a lowercase letter. So starting with an uppercase letter is technically allowed. But typically when you name something starting with an uppercase letter, it means something else in Java. Sometimes it means like a special variable, or it could mean like a class name. So typically just for your garden variety variables, we want to start with lowercase letters. And then after that, we can give it any combination of numbers, letters, and underscores, and we're good. In terms of good programming, you should declare the variable near where you're going to use it. Because then later, if you're doing your coding and you're like, I want this variable, where is it? Oh, it's all the way up there. Why am I doing that? So declare it near where you're going to use it, and it helps for readability. For terminal input output, when you were using Python, you probably used just print, and it's been a while since I did it. Is it like input for Python? Yeah, okay. In Java, it's a little more complicated. System.in especially is a little more complicated. We'll look at that later. But we've already seen using system.out. That's how we print to the console, to the terminal. So if we give a value to this long variable name, remember we can do sysout and then enter, and we can print my very long variable name. And if I save it and run it, the terminal shows up and it prints that. So the way we access the console or the terminal is with system.out. And then there's different print functions. Println is the most common. Yeah. We can kind of see sometimes we say system.out and then dot. This whole list shows up of like, here's all the different kind of functions we can call from system.out. So if you want, you can scroll through and figure out. Up here, these are like the ones that we really care about. There's println, there's printf, just print, which doesn't add a new line, and others. So yeah, so we can see all the options that way. But for now, I typically use println. And so ln is it adds a new line after finishing printing. So that's why when we say print hello world and then this gets printed, there's a new line between hello world and this gets printed. So if I change hello world to just print, then see there's no new line. So println adds that new line after it. Add that back. For system.in, we're going to use scanner. That's not a primitive type. We'll talk about it. We'll get plenty of practice. In terms of operators, probably all ones that you're used to. For assignment, we can say, like, let's go down here and let's say we'll have a variable z equal to 2, and we'll say they initialize ABC, let's have it be 5. So we can say ABC minus equals Z. This is equivalent to ABC equals ABC minus Z. It's just shorthand. Similarly, like plus equals or times equals or divides equals, those all work. And so that's just shorthand for this variable equals that same variable operator, the variable on the other side of the equal sign. Your arithmetic work as you would expect, plus, minus, multiply, divide, as they did in Python. Did you go over the percent, the modulo operator at all in Python? Yes, seeing some head nods. Cool. It works the same. So like 4 modulo 3 is the remainder of 4 divided by 3. So for this one, it gets us 1. Let's test that out. So this should be 1. I can also run it by function F5. And there we go. That's 1. The unary operators did you do these in Python? No? Okay. So, let's take Z, our variable Z that we have. We take Z and then we do Z plus plus. And then we print Z again. What plus plus or minus minus, this is equivalent to Z plus equal 1. So just adding 1 to Z. And then similarly, Z minus minus subtracts 1 from Z. So if we do this, so Z is initially 2. This adds 1. So what do we expect to be here? What do we expect to print? 3, right? Okay, I'm gonna comment this out for now. Okay, so what I just did, I wanted to print some string to make sure that I'm looking at the right thing. So here in Java, the simple way is to do strings, which is double quotes. And so I said Z is, close the double quotes, and then I have a plus, and then the variable name. The plus is important. It's different from Python where we can just do commas. Yeah. There's also format. You can format the print statement. We'll look at that later. But if I run that, then we have Z is 2 and Z is now 3. So plus plus works. There's a little difference between, so you'll see that like X plus plus and plus plus X, both of those add 1. So the plus plus operator just adds 1. And whether it's before or after the variable, is just determining when that operation happens. So let's set up, do I have X? I'm not sure. Let's say X is 5. Let's set Z is 5 as well. I do already have it. Where is it? It's here. Okay, so I'm gonna have X and Z as 5, and I'll increment X on one side, I'll increment Z on the other side, and we'll see what happens. So I have X plus plus, and then the plus to say, now we're adding a string to this. Then I've got versus, then I have another plus, and then over here I've got plus plus Z. So we're gonna compare what it looks like when the unary operator is on the right-hand side of the variable or on the left-hand side. What do we think is gonna happen? Take some wild guesses. Talk to your neighbor. 10 seconds. What do you think's gonna happen?
You know, I think I'm do the same thing. Let's see another way.
Okay, what are we thinking? So do we expect? Okay, here's my thinking. Do we expect 5 versus 5 or 5 versus 6 or 6 versus 6? Who votes for 5 versus 5? Who votes for, there's another option here. Who votes for option 2, 5 versus 6? Okay, some votes here. Who votes for 6 versus 5? Who votes for 6 versus 6? Okay, so we expect either the second one or the fourth one to happen. Let's see. Five versus 6. Someone want to take a guess at why this is happening? Go for it, Lachlan.
It's just passing 5 rather than 6 because it hasn't added to X yet.
Yeah. So the thing that's happening is we're doing this operation at the same time, or at asterisk, at the same time as we're sending this string to be printed. And so the difference here is when that operation happens. When does the when does the 1 actually get added? So here, so this is what we got, 5 versus 6. And so let's start with the plus plus Z. So with plus plus Z, it adds 1, then sends the new Z to be printed. With X plus plus, it sends X to be printed, then it adds 1. So if let me duplicate this line, and I just want to print X and Z because they should be the same, right? They should be 6 now, if I'm not doing any more addition to them. So when I do that, then I indeed see that 6 versus 6. So after this operation, they're both 6. So what happened here is Z got added, then sent to print. X got sent to print, then got 1 added to it. And so that's why, so all this to say, it's a very small detail, but sometimes when you're designing a solution, it matters. Like it matters whether I'm adding one now versus whether I'm adding one after this thing happens. So it's just good to know for you that this is one of the options that you can play around with. Any questions so far? Okay. Let's keep on moving. So in Python, you had some logical operators, like you can say and, or, and not. In Java, we do have those operators. They're just spelled a little bit differently. So let me see. I don't have that in my notes. I should have that in my notes. So let's try. Some logical operators. So in terms of and, so let's say, so we know true and false is false, right? Pretty sure. So in Python, we would say the actual word and, but in Java, we say two ampersands. So this is how we say and. For or, so we use two what we call pipes. So pipes are there's the backslash. On my keyboard, it's above the enter key. You have to press shift and then it's like a long I. Those are pipes. Can I actually print this? Let's see. I didn't test this ahead of time, so there we go. Okay, so we can see that true and false is false, but true or false is true. So we've tested and we've tested or. If we wanted to say, let's say we wanted to say not false, the way in Python we would say the word not, but in Java we use exclamation point. Exclamation point is not. That's how we negate a logical statement. And so when we print this, we expect true. Because the opposite of false is true. All right, so we've got not, we've got and, we've got or. Inequality, that works the same as Python. So we've got the exclamation point equals, that's not equals. The two equal signs are testing for equality. I think that was also in Python. This one is less than or equal to, greater than or equal to, less than, greater than, all standard. Let's say, let's ask if z is not equal to 5. We would expect this to be true, because if z is 6, then z is not 5. And then let's check if x is equal to 6, which we would also expect to be true, because x is 6 at this point. I'm going to comment those guys out so we don't have so much cluttering the console. And so down here, we've got true and true as expected. Okay. Java limits implicit typecasting. That's a sentence. What does it mean? Let's say we are working with some integers. So we're going to look here at typecasting. And so let's say we've got int a, and let's say a is initially 6. Let's say we've got b, which is 10, 2 integers, that's fine. And let's say we want to save them in a quotient variable that is a over b. So 6 over 10. If we saved it as an int, let's I probably already defined b. No, b is a Boolean. Where is it? There it is. Okay, so I've got a and b, and I save their quotient and print it out. What do we expect? For what do we expect it to print? Who votes for 0.6? Who votes for 0? Okay, at least one vote for 0. Who's not sure? Okay. 0. So what's happening here is we have saved 6 over 10 as an integer. It's rounded down. So 6 over 10 is 0.6. Round down, 0. So when we save it as an integer, we get 0, which is not very helpful if we want to actually know what the quotient is. If we know that, so we know that 6 over 10 is a floating point number. We know it's a decimal. So if we save it as a double, maybe that'll fix our problem. Boo, it didn't. It's still 0.0. At least we've got a decimal point in there now, but it's still 0.0. And so what's happening here is we are doing implicit typecasting. So what we have done is we've said, here's 2 integers, a and b, divide them, save it in this double variable. And Java's like, okay, you're dividing 2 integers, so I'm going to save it as an integer, but you've told me to save it as a double, so I'll add a decimal point in there to be nice. So what we want to do is we need to say, this variable, I really, really want it to be a double. And so in order to do that, we have to cast it. And so we have to say, no, for sure, I'm dividing a and b. I know they're both integers. I want the answer to be a double. And so we add that in parentheses before we're doing this operation. So this is our explicit typecasting. So Java limits implicit typecasting when we don't say anything. So we have to do explicit typecasting where we say, here's the type that I want you to save this variable as. So if we do that, then we get 0.6. So we need to explicitly cast to get 0.6, both the number and the decimal point in there. Any questions on that? Okay. We're going to look at if, while, and for statements. They look a little bit different than they did in Python. Let's look at if first. So let's do that so we can scroll up here a bit. So for if else, wave C. I do. Let's call it D. Okay, so let's say we've got a integer called D and its value is 2. So let's say so the way that we say if something, so if we're checking if D equals like 100, we say that with the word if. So we have the word if, then we have parentheses. Inside the parentheses, that's where our logical statement goes. So something that resolves to true or false. So D equals 100, that's either going to be true, or it's going to be false. And so we put that inside parentheses after the word if. Then we've got curly brackets. And then in here, this is what we do when this is true. So when D is equal to 100, we do this. Maybe we print $100. Otherwise, so we can say it with else. We can also say else if, and let's say D is equal to 5. So for else if, we say the word else space the word if, and then we have our logical condition also in parentheses. And then the curly brackets, and then whatever goes in the curly brackets, that's what we do if this condition is true. And then for else, we just have the word else, and then curly brackets, and then so in our case, since we know D is 2, well, let's play around with it. So for now, we have D as 2, so it's not going to be equal to 100. It's not going to be equal to 5. So then it falls under the else category. So we expect it to print, you have $2. There we go. Great. If we had, let's try D as equal to 100, then we get $100. If D was equal to 5, we would expect just the text $5. And there we go. So in Java, you have the word if or else if, and then the logical operator goes inside parentheses, and then we've got curly brackets. Technically, if we only have one line of code, we don't need the curly brackets. So legally, if we took away the curly brackets on this else if, that's fine. So if I run this, it still gives us $5. I like to include them for clarity's sake, and also usually for the fact that I'm typing something and I'm like, I only need one line. I don't need curly brackets. And then later I add more lines and I'm like, oh no, I need curly brackets. So I personally like to include them, but if you know for sure you're only going to have one line in this if statement, then you don't need them. Okay. Questions so far? All right, so that's if statements. For while, that's probably the closest one. So the continuing theme of Java versus Python, Python had white space. Java uses semicolons and curly brackets. So For while loops, we need the word while, and then the condition to continue is similarly in parentheses. So, then we've got our curly brackets to say, here's the code that I execute when this condition is true. So we have the word while, in parentheses, we have our logical condition. In the curly brackets, we've got all of our statements. And so let's say, I don't know, let's take away the money until we're at 0. Wait, no, I need to change that. Okay, so if our condition is while D is greater than 0, we'll take away $1 at a time. Then once we're done, it'll print you have $0. So let's try that. And there we go. So that's how we do a while loop. In terms of a for loop, you remember in Python how there's like 2 ways of doing a for loop? There was like, if you have like a list X in Python, and then you can say like for item in X, like print item, right? That look familiar? Did you also look at for I in range length of X? Print item or print X at I. Does that look familiar? Cool. So this, we can do both of there. Yeah, so these are both ways of doing a for loop. We can do both of these in Java. This one is called why am I suddenly blanking on the name? Enhanced for loop. It'll come to me. But yeah, so there's like an iterative for loop where we have some variable where we're going to add one until we get to the end. And there's ones where we're looking at like each item in a collection. And that's what this one, like for item in X. So we're going to try and do these. For now, we're just going to look at the second one. We'll look at the first one in a bit. I think in the lab, you'll look at the first one as well. But in Java, so we do have the word for, and then we've got parentheses. And there's 3 things that go in parentheses. We've got let me comment this line out so in the first thing in the parentheses, we've got some initialization, and then there comes a semicolon. Then we have a condition, and then we have some incrementation. And then we've got curly brackets and then some statements. That's what a for loop looks like in Java. So let's say we want to print the numbers from 1 to 10. So we'll say for parentheses, we'll say int I will start at 0. Let's say for I less than or equal to 10. So as long as I is less than or equal to 10, we're going to do the statements in the for loop. And then here's how we're going to deal with the value of I after each round of the loop. So we'll say I plus plus. And then we'll have our curly brackets and we'll say, not print system error, print system out, and we'll print just I. So we're printing the numbers from 1 to 10. So first, let's make sure that it does what we want it to do, and then we'll talk about it. So if we run this, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks good. So what's happening here is when we start the for loop, we set aside, here's a variable called I, starting at 0. So as long as I is less than or equal to 10, I'm going to execute this loop. So starting, I is 0. Is that less than or equal to 10? Yes. Therefore, I'm going to print I. So that's how we get 0 printed. Once that's done, we add 1 to I. We do I plus plus. All right, now I is equal to 1. Is I less than or equal to 10? Yeah, because I is 1. So then we print it. Then we add 1. Then we check, is 2 less than or equal to 10? Print it, and so on. So then when we get to the end, so I is equal to 9, all good, print it, add 1, I is equal to 10. 10 is less than or equal to 10, so we print I, and then we add 1. Now I is 11. Then we ask, is 11 less than or equal to 10? No. So we don't print it. We're done with the for loop. That sound good? How are we feeling about that? Cool. Okay, so we've done while loops. We've done for loops. Yeah, choosing between while and for loop is mostly a personal choice. Sometimes it's easier to do a while loop depending on what you're doing. Sometimes it's easier to do a for loop. That's a decision that you, the programmer, can make. Maybe it's like, oh, I like this one better, so I'm going to use it. Or maybe, maybe you're making an app and you have to wait for someone to click something. And so in that case, maybe a while loop would be better. So that's a choice that you, the programmer, can make. We can also do while loops. And so do while loops look pretty much like while loops, except it does the thing first, and then it evaluates the condition. So in while loops, it evaluates the condition first, and then does stuff. Do while, it does the thing first, checks the condition. If the condition is true, it'll keep doing the things. So if we wanted to do this, we would change it from just while to we would, I'll cut this. So we can say do this while D is greater than 0. So this ensures that we will subtract $1 at least once. And so whether you want this or a normal while loop also depends on what exactly you're trying to do. Okay. Okay, so we've looked at if and else if. We can also look at, there's a short way to do that in Java. It's called the conditional operator, where we have, let's see my D. So let's say E is 2 and F is, not F, let's say G is 50. let's say I want to have if E is less than or equal to F, then I want to say the min is E. Otherwise, let's say this is the code that I want to do. I want to, let's also have a min here. So I want to save the min of E and G. That's supposed to be G. So I can do this the long way. Perfectly fine. That's valid. I can also do it a shorter way. So a shorter way of doing it is to say min is equal to E less than or equal to G question mark E colon F semicolon. Why is that not working? Mismatch. F. That's because the F is supposed to be a G. Okay, so that's a statement that we typed. What does it mean? So on the left-hand side here, min equals, we're saving whatever the result of this is. So let's look first here. This is the condition. That's E less than or equal to G. It's either true or it's false. After the question mark, we have, here's what happens if this logical statement is true. So if E is less than G, we're going to give you E. And then after the colon, we're saying if E is not less than or equal to G, we're giving you G. So, so we have some condition. And then we have a value if that condition is true after the question mark. And we have the value if the condition is false after the colon. And so this is our conditional operator. So what we're doing here by setting min equal to it, we're saying, because I just have E here, so we're saying min is going to equal E if E is less. If G is less, then I'm giving min G. So that's why I have min equals the result of this whole thing. If we were going to use it in a function, we would need just replace like min equals with return. And then here's the conditional operator. We wouldn't have like E less than or equal to G, return E, or return G. That won't work. So we have to have a return outside the whole conditional operator. So this is not going to work. You're going to get errors. Questions on this so far? Okay. So that's conditional operator. Lets us do like potentially a lot of code in just one line, so it's very compact. You're talking about methods. So in Python, you worked with functions. In Java, we call them methods. We also sometimes call them functions because I forget. They're also sometimes called procedures. But typically we call them methods when we're working in Java. So in Python, when we wanted to have a method, so I'm going to scroll up all the way to the top. If you need me to go back, let me know. So within my curly brackets for hello, I'm going to have a method here. So I'm outside the main method. I'm outside those curly brackets. I'm within the curly brackets for the class hello. And in Python, I would say like def function name, any arguments here, and then a colon. In Java, we do have the function name. We do have any arguments, and instead of a colon, we've got curly brackets. But we need a little bit more information. So we need the return type of the method. So in Python, we don't necessarily need to specify it. We could, that's an option. But in Java, we need to know what kind of data is this method going to return? What sort of, what type of variable are we going to get as a result of this method? So we need a return type. We also need the name. In parentheses, we've got any parameters, and then we've got curly brackets, and then statements. So we already have a method here. So the return type here is void, which means we're returning nothing. We've got the name of the method, which is main. We've got our parameters. We've got our parameters, which is a variable called args, and its type is a string array. Talk about that in a bit. And then in the curly brackets are all of the statements that we've just been working with. There's additional information. We'll talk about this. For now, we'll have our methods be public static. We'll talk about what that means and what sort of other options we can have. But for now, don't worry about this and just make it public static. Okay, so we did a min method. Let's make that into an actual function. Instead of just having it in our main, let's pull it out and make it a function. So I'm going to have public static. Again, we'll talk about that. Just have that there, and we'll talk about why later. Our return type. So first of all, our name is min, and we're going to take two integers, a and b. What's our return type if we're working with two integers? What kind of data are we returning? Integer, right? We're finding the min of two integers. The result is an integer. So public static int min. And so right now we've got an error because this method must return a result of type int, and we just haven't done that yet. Okay, so we're going to have a return statement that's spelled just the same way as it was in Python. And we'll say return, and it's the same thing with the conditional operator. So is A less than or equal to B? If it's true, we're returning A. That's the smaller one. Otherwise, we're returning B. That one's the smaller one. And so there we go. One line function method. Hooray. Let's test it. Let's make sure it works. Okay, so down here, we're going to do sys out, and we're going to print min of, someone give me two numbers. Hmm? 5 and 7. 5, 7. Okay, so when we call min of 5 and 7, let's maybe add a string here. Min is close quotes plus operator. If I run that, then we get 5, as expected. And let's try swapping it to make sure it really works. So min of 7 and 5 we still expect to be 5. And there we go. So the min is still 5. Okay. What if, so we've got our min method. Let's try and make a max method. So let me copy and paste this. Let's have a max method instead. And so to change it, we just change this less than to a greater than to flip it. Or we could, or if we did this, we could say A is not less than or equal to B. That's also a way to get there. So we have 2 methods now, min and max. Java also allows for method overloading, which is a term that means we can have a method with the same name, but different parameters. So the things in here are parameters. When we actually go to use it, so up here, when we're defining the max function, A and B, those are parameters. Down here, when we actually call it, like if we called the max of 7 and 5, 7 and 5 are our arguments. So those are the actual things that we have passed. That's just a little terminology thing. But the thing with the overloading is we can have 2 methods named max. We just have to distinguish them in some way. And so one of the ways we're going to do that is, actually, let me just write it from scratch. Let's say we want, instead of finding the max of 2 integers, let's say we want to find the max of 3. So first we have to, let's say first we have to find the max of A and B, and we'll save that in D, and then we'll find the max of C and D. So focus on the first 2, then focus on the next 2. So then that's C greater than or equal to D. If that's true, then we return C. Otherwise, we will return D. Yeah.
We call our second max function in the third one.
Yeah, we could totally. So instead of this, we could say max of A and B. And then here, instead of this, we could say return max of C and D. That's right. So so that's overloading. So the overloading is we have the parameters in a certain way. So we know there's a method called max that takes 2 integers. There's also a method called max that takes 3 integers. So when we call max with only 2, it knows, oh yeah, it's the one with 2 integers, the 2 parameters, both ends. When we call max with 3 integers, it knows, okay, I'm going to go find the one with 3 integers. So it knows which one we're going to reference. The only trouble is if you were going to try and define max with 2 integers and then 2 integers, that would probably be a problem, because then it's like, which one do I choose? Because that's a legitimate question. But as long as there's a difference in what we call the method signature is just this line that defines, here's the return type, here's the name, here's the parameters. That's the method signature. As long as there's a difference between 2 method signatures, they can have the same name, and Java will automatically choose that's the one you want to go with. Okay, let's test that. Make sure it works. So we have the max of 7 and 5. Someone give me 3 numbers. Let's go 1,000. Okay. 1,000, 5,839, and a very long number beginning with 5. Clearly, the very long number beginning with 5 is the one we want. Yeah, sorry. And it works. Good so far? All right. So that's method overloading. You should be careful of the scope in which a method is declared. We'll maybe see some examples of why that matters when we start to talk more about classes and reference types. But just be careful, like be mindful of where you define a method, so to make sure that you're able to access it. And also being careful of scope in terms of variables. So like, where's VS Code? So I have this variable G in my main method, but up here in max, I can't do anything with G because we're in a different scope now and it doesn't know what G is. So when we're in a different function, the scope changes. And so we can't necessarily access variables that were in a different place. So in that case, we would, if we really wanted to access G, maybe we wanted to add it as a parameter. So we're in a different scope now. Okay, to the code. We're good? All right, yeah, take your time. All right, all good, okay. Okay, I think that's, all right, so to finish this off, so in terms of what makes the programs actually run, we need what's called a Java virtual machine. And so the steps to get there, we've got our Java file, our .java, that's what we're typing in. So we've got hello.java. When this file gets compiled by the JVM, it gives you a .class file. You can actually find them in the bin folder in your directory here. We've got hello.class, app.class, someclass.class. That's the compiled Java file. So it gets compiled. From there, it runs the compiled file to get this output. So let's see if we can see it when yeah, okay. So there's all this gobbledygook at the beginning of when we are running this thing. It says CD, which is let's go to the directory where the code lives. And so for me, it lives in my Google Drive. And then this is saying run my JDK. That's where I've installed it. And then it's running our hello file, and it lives in the bin. So when we're running it, it runs this .class file. So we write the .java file, compiles, we get a .class file. It runs that .class file. That's how we get output. So the note, we can only run .class files. We can't look into it and see here's what the code is. So typically for submission in this class, you need to submit your whole project folder. In case you, like for the active learning, when you're submitting a file, make sure not to submit the .class file, because I can't actually see your code. So make sure you're submitting the .java file so that I can see your code, because .class is just, we've compiled it, it's a package ready to go, and not the actual code. And then the thing to know about Java is that everything in Java is either a class or part of a class, usually.
We're submitting a Java file, with a bunch of different classes in there, and then they're not all defined in there, and we will submit the files that are defined as well.
Yeah, so for typically, so there's a class. So in our case, we have a public class hello. Each class typically is part of its own file. So if we have a class called like some class, that's in its own .java file. And the other thing is the name of hello.java needs to match the name of the class. So the capital H hello, those two have to match.
So we can't run functions.
You can run functions in different files. We'll talk about that. You'll also see that actually in the lab. So there's, let's see, do I have this up here? Let's go to statistics. So like, actually, no, let me go back to statistics. So in the lab, we have functions in the statistics class, which you're going to implement, and then we call them in a different file. So we implement them here, but there's no main method in this class. There's a main method in statistics demo, where we've got our public static void main. And here is where we call those different functions. And so the way we do it is we have the name of the class dot name of the function and any arguments. So that's how we call methods that are in a different file.
Are you gonna have to submit anything that requires us? Are we submitting one file is all I'm asking? Or are we gonna be submitting?
Right, so for the active learning, typically just one file. For the labs and the homeworks, you're going to zip your entire project, which I should show you how to do that. So let's say that this, okay, it's not, but let's say that my CS222 in class, let's say that that's my lab assignment. I'm all done. It's tested, great. We still have 10 minutes, yeah. So what I want to do is I'm going to right click on a file in here, and I can reveal in Finder, or probably reveal in File Explorer if you're on Windows. That brings up a Finder window, or you can just navigate to wherever this project lives. So I'm going to go up one level because I want to zip this entire project folder. So on Mac, I do Command up arrow. That brings me up here into my workspace. Or if you want to just navigate there from your File Explorer, that works too. So like if I'm in my 222 class, then I go into Workspace. This is the project file that I want to zip up. So I right click, and on here on Mac, I do compress. On Windows, I believe it's send to zip. And so then I can compress that. And then this zip file, that's what you turn into Canvas for the lab. So you're going to zip your entire project folder, turn in the zip file to the lab. And I think I have it set up so if you try to submit any other kind of file, like if you just submit your .java file, it won't accept it. So make sure you just zip it and then turn it in. Okay, so any other questions? Okay, we've got about 10 minutes. So we'll talk about chapter 2 on Tuesday. So I want to give you time to work on the lab. Yeah, question. Oh, yeah, okay. Wait, sorry. I'll head back there. For active learning today, just submit your updated hello.java. And fill out the Wentz meet. And the rest of the time is yours to just work on the lab. Thanks for coming. See you on Tuesday.